Okay, so this brings us to respiration in mammals. So remember, the reason why we have our lungs is that we are terrestrial and we need to be able to get a lot of oxygen and reduce our water loss, right? So also we are endothermic. And so this also maybe explains why aquatic mammals like whales and dolphins still breathe air rather than having gills. Gills are highly vascular, they have a lot of blood vessels, and so that is a very quick way to lose your body heat, is having gills exposed to the external environment. And so even aquatic mammals breathe air. When we look at respiration, we see that there are parts of the respiratory system that are the conducting zone. So we have conducting zone. And the first one is the nasal cavity. People breathe or should be breathing through their nose and not their mouth. So you want to inhale and exhale through the nose. The reason why is the nasal cavity, one, helps to filter the air. So it filters the air. You know this if you've ever worked in a dusty environment, that the mucus and the hairs, you get boogers, right? That's filtering that. If I was just breathing in with my mouth, if I'm a mouth breather, then I'm going to get all that dust into my lungs, and that would be a very bad thing, right? So it filters air, it humidifies air, okay? And it also allows for olfactory perception or sensation, olfactory reception. That is smell, which we're going to talk about when we get to the senses. So our respiratory surface is not in our nose, obviously. We're not actually getting oxygen across and into the blood. But the nose is actually, the inside of your nose, your nasal cavity, is actually very thin. And it produces mucus and it produces water and it humidifies. That would be the part of, you don't actually get your finger in that part, so you're this. And then the very superior region of that actually has olfactory nerves that dangle down and bind chemicals that we breathe in and then send us information about smell. So from the nasal cavity, it goes into the pharynx, which is the common opening to the digestive and respiratory systems. From the pharynx, it goes into the glottis. The glottis is actually the opening into the larynx. It is covered by the epiglottis. So remember that the epiglottis is what actually helps to protect and prevent stuff from going into your trachea. Your trachea is supported by tracheal rings. You can feel the rings. Your larynx is your voice box. So let's talk about the larynx. So that's sometimes referred to as the voice box. It tends to be larger in males. They tend to have deeper voices because of that. But it actually has vocal cords in it that vibrate, so that when we breathe out, we can cause those vocal cords to vibrate, and they create a sound, a vibration that moves out, and people can hear us speak. So that's the larynx. And then we have the trachea. Now the trachea is really interesting because it has mucus and cilia. And so our trachea is constantly moving mucus up and into our throat, and we are generally swallowing it. So when people smoke cigarettes, one of the things that happens is it destroys the cilia. And so specifically, like overnight, when they're not coughing and they're sleeping, they tend to build up mucus in their trachea. And so they wake up in the morning and they cough and they cough and they cough because they have to get rid of all that mucus that in a non-smoker would not be staying in the trachea. The cilia, interestingly, can repair themselves. So it's not like a permanent thing. So you can get rid of most smokers' coughs, maybe not the problems of diffusion of gases, but the cough can go away once you stop smoking. Okay, so we have the trachea, and then we have the two bronchi. These branch into the right and left lungs, and they branch into smaller bronchioles. So these are small bronchi. And then they finally branch into alveoli. And the alveoli is where we actually have the respiratory membrane. That is where diffusion of gases takes place. So let's look at an image. This is my nasal cavity. We could, if we had to, breathe through our mouth, like if we have stuffy noses because of a viral infection. If this upper respiratory tract becomes too clogged, we could also open up a hole, a tracheotomy that goes directly into the trachea. But you can imagine that that would be kind of scary because you don't have the filtering mechanism there that you have up here. They branch into the bronchi and then into smaller and smaller bronchioles. So this would be a bronchiole coming in, and then we have the alveoli. And you'll notice that the alveoli are highly vascularized, which means that they have capillaries. These capillaries are also thin-walled, so that allows for gas to move out of the circulatory system. So carbon dioxide is removed, and then oxygen diffuses in. Our design of our system allows for optimal diffusion. So if we look at the flow of blood, let's see.